Hello everyone, my name is Lalit Chauhan and welcome to the YouTube channel Mathletes. So in this video we are going to solve some of the questions based on factors. We already solved some concepts based on factors in the previous video. If you have not watched that video till now, please go and watch that video and then try to learn these questions. So getting started, what questions we are going to do in this? If you see this first one, the question is, find the number of prime factors in the product 30 raised to the power 5 into 24 raised to the power 5. Now what is the meaning of finding the number of prime factors? We know how to find the factors of any number, but how to find the prime factors? Now what I can do is, I can simply write this number as 30 raised to the power 5 into 24 raised to the power 5 as expanding this 30 as 5 multiply 6 raised to the power 5, and 24 can be written as 6 4 times is 24 raised to the power 5. Now we can further write this one as 5 into 2 into 3 raised to the power 5 multiplied by 2 into 3 into 2 square raised to the power 5. Now further we can write this one as 5 raised to the power 5 multiply by 2 raised to the power 5 multiply by 3 raised to the power 5 multiply by 2 raised to the power 5 multiply by 3 raised to the power 5 and then 2 raised to the power 10. So I can further write this one as, we have 2 raised to the power 20 multiply by 3 raised to the power 10 multiply by 5 raised to the power 5. Now if we have to find the number of factors in this, what we will do, we will just simply add 1 in the powers, that is 20 plus 1 21, 10 plus 1 is 11, 5 plus 1 is 6, and then we will multiply all of them. But as we have to find the number of prime factors in this, so prime factors, I have already told this, that every number is the multiple of prime factors. There is no number in this universe which cannot be factorized into prime factors. Every number has factors of prime. So we have this 2 is written how many times? We can say this 2 is written 20 times. This 2 is written 20 times. Similarly, this 3 is 10 times. And then this 5 is written 5 times. So we know this, that 2 is a prime number, 3 is a prime number, and 5 is a prime number. So 2 is 20 times. So we have 20 factors of 2, 10 factors of 3, and 5 factors of 5. So overall we have 35 factors that are prime. So this 35 will be the answer for this question. Now let us solve the second one. The second question is, they saying consider number n equals 180 raised to the power 20, and we have to find how many factors of n are perfect squares. Now we know this, how to find the perfect squares. But first of all, we need to factorize this number into the number of primes. Like this 180 raised to the power 20 can be written as, I can write this number as 9 multiplied by 20 times raised to the power 20. Further it can be written as, this is 3 square multiplied by 20 can be written as 5 multiplied by 2 square raised to the power 20. Now I can further write this number as 2 raised to the power 40 multiplied by 3 raised to the power 40 multiplied by 5 raised to the power 20. Now as I have to find the number of perfect squares, so what I have to do is, I simply have to divide these powers by 2 and then add 1 in them. Similarly, again dividing this power by 2, adding 1 in all of these powers. Now the question is based on cube, I will simply divide it by 3. If the question is based on 4, then we will simply divide the powers by 4. So this will be equal to 21 multiplied by 21 multiplied by 11. So this 21 square is 441 multiplied by 11. Now whenever you encounter such kind of number, like whenever you are multiplying any number by 11, what you do, there is a short method for this. We can simply write this unit digit as it is, and then moving towards the left we have to add another number. While moving towards the left we have to add each number. That is 4 plus 1 is 5, again 4 plus 4 is 8, and then writing this last number as it is. So we got this as 4851. So we can simply say that there are 4851 factors of 180 raised to the power 20, which are the perfect squares. Now let us see this question number 3. The question is, how many factors of 72 raised to the power 72 are perfect squares but not a perfect cube? Now what is the meaning of this? It means I have to find the perfect squares, but those perfect squares should not be the perfect cubes. For example, let us say I am taking the example of some numbers. For example, I am saying, let us say 64 is a number. Now I can say 64 is the perfect square of 8, but 64 is also the perfect cube of 4. So 64 is the square of 8, so I have to find such numbers which are perfect squares, but it should not be a perfect cube. So this number is a perfect square as well as perfect cube, so we have to eliminate such kind of numbers. Similarly, there can be many numbers which are perfect squares as well as perfect cubes, so we have to eliminate those numbers. So what we can do is, first of all we need to factorize this number and then writing down it in its primes. This 72 can be written as, this is 2 cube, that is 8, multiplied by 9 times is 72, that is 3 square, raised to the power 72. Now I can again write this number as 2 raised to the power 216 multiplied by 3 raised to the power 144. Now while finding the perfect squares, again the way is simple. You just have to divide it by 2 and then simply add 1 in it. Dividing this one by 2 and then adding 1 in the powers. The number of perfect squares are, this is 109 multiplied by 73. So when we will multiply this 109 by 73, I will get something as So I can say that there are total 7,957 factors that are perfect squares. There are total 7,957 factors that are perfect squares. But as we have to eliminate such kind of numbers which are also the perfect cubes, so what we have to do is, I will show you a simple example here. Now this 202 to the power 216 is written. Suppose if I have to expend all the powers of this, then what I will do, I will write it like this. I will write it as 2 raised to the power 0 plus 2 raised to the power 1 plus 2 square plus 2 cube plus 2 4 plus 2 5 plus 2 6 and then so on. So this will be equal to 1, this is equal to 2, this is equal to 8, sorry, this is equal to 4, this is equal to 8, this is equal to 16, then this is 32, then this is 64, and then similarly I will write some more powers. I will write 2 raised to the power 7, this will be equal to 128, 2 raised to the power 8, this will be equal to 256, 2 raised to the power 9, this will be equal to 512, then 2 raised to the power 10 is 1024, then 2 raised to the power 11 is 2048, and then 2 raised to the power 12 is 4096. Now by writing all this, I just wanted to show you that what is the meaning of that answer factor should be perfect squares but not perfect cubes. Now you can see this, that this number is a perfect square. Similarly, this number is also a perfect square, this number is also a perfect square, and this number is also a perfect square. But this number is a perfect square as well as perfect cube. Similarly, this number is also a perfect square. Then similarly, we have many such kind of numbers which are the perfect squares. Similarly, I can say that this number is also a perfect square. This is the perfect square of 32. Then I can say that this number is also a perfect square. All these numbers are the perfect squares. But this 4096 is a perfect square as well as the perfect cube. This number is the perfect cube of 16. So while counting the squares, we also counted some cubes. So in order to eliminate them, you can see this, that this 64 is appearing after 6 steps. Similarly, this 2 raised to the power 12 is again appearing after 6 steps. So what we have to do, after every 6 steps, we have to eliminate such kind of numbers. So what is the short way of doing this? We can simply take the LCM of 2 and 3. That is, 2 means perfect square and 3 means perfect cube. So the LCM of 2 and 3 is equal to 6. So we have to eliminate such kind of numbers which are repeating after every 6 steps. So what we can do is, for perfect 6, we need to divide it by 6 and then add it 1. Similarly, 144 divided by 6, adding 1. So what we will get from here, we will get those numbers which are perfect squares as well as perfect cubes. So solving this, we get 37 multiplied by 25, and this will be equal to 25 7 times is 175, then 25 3 times is 75. This is equal to 925. So 925 factors are there which are perfect squares as well as perfect cubes. So we only have to find the perfect squares. So what I have to do, I have to subtract 925 from all the perfect squares, and this answer will be equal to 7032. So I can say that there are 7032 factors which are perfect squares but not perfect cubes. So C will be the answer for this question. I hope all of you understand this one. Now let us see this fourth question. The question is, how many factors of 226,800 are perfect squares excluding 1? So again we have to find the perfect squares, but they are simply saying that we have to exclude 1 in it. That is, if I have to find the perfect squares, what I can do is 2268, and then I can write this one as 100. Now factorizing only this one, and this we can simply write it as 5 square multiplied by 2 square. This is now we can write this number as now for finding the perfect squares, what we used to do, we used to divide these powers by 2 and then add 1 in them. So I can say that we have total 18 number of factors, including 1, because 1 is always included. 1 is included when we write this 2 raised to the power 4 as 2 raised to the power 0. So 1 is included in that case. So now what we have to do, we have to exclude 1 from it. So I will just subtract 1 from it, and then I can say the answer will be equal to 17. So overall I can say that we have 17 factors excluding 1. Now this another question is, how many factors of 360 raised to the power 20 are perfect squares as well as perfect cubes? Now we already know this, that whenever they are asking about that, it should be a perfect square and it should also be a perfect cube. So we just simply have to take the LCM of these two numbers. I can say the LCM of 2 and 3 is 6. So what I need to do, I need to convert first of all this one into prime factors, and then dividing the powers by 6 and then adding 1 in them. So I can write this 360 raised to the power 20 as now we can say, or we can write this one as 2 raised to the power 60 multiplied by 3 raised to the power 40 multiplied by 5 raised to the power 20. Now as we have to find such kind of numbers which are squares as well as cube, or I can say whose root will be, that is, if we have to find the square root or cube root, similarly in case of 6, its root will be 6th root. So similarly in case of powers, it will be 6th power. So such kind of numbers will be, this is 60 divided by 6 plus 1, this will be equal to 40 divided by 6 plus 1, and this will be equal to 20 divided by 6 plus 1. So we can say this is 11 multiplied by, this is 6 times, it is only divisible till 6 times, so this is 6 plus 1 is 7, then this is 3 times 3 plus 1 is 4, so this is 7 for 28 multiplied by 11 is, this is 8 to 10 0 308. So I can say that overall total there are 308 factors which are perfect squares as well as perfect cubes. So the first one will be the answer for this. Let us see this question number 6. The question is, what are the total number of factors of 60 that ends with 0? Now what does this mean? Ends with 0. We know this, that we get 0 only when we multiply 5 with any even number, and the smallest even number is 2. That is, when we multiply 5 with 2, we always get a 0. So what I have to do, I just have to find or identify the numbers that are divisible by 10 or that ends with 0. This is what I need to do. So total number of factors of 60, what I can do, I can write this 60 as this 12 5 times, or I can write it as 4 multiplied by 3 multiplied by 5. This in turn can be written as 2 square multiply 3 raised to the power 1 multiplied by 5 raised to the power 1. Now as I have to find the numbers which are divisible by 10, it means ending with 0 means divisible by 10. So such kind of numbers which are divisible by 10, it means we have to obtain these numbers. We get 10 only with the help of 5 and 2. So what I need to do, I have to take 2 raised to the power 1 and 5 raised to the power 1 common out of this. Taking out common, what I get, 2 raised to the power 1 multiplied by 3 raised to the power 1. Now as I have told this earlier also, that whatever is left inside, we just have to do the same process as we used to do in finding the simple number of factors. So this 2 raised to the power 1, this can be written as 1 plus 1 is 2. Similarly 3 raised to the power 1, it can be written as 1 plus 1 is 2. So this is how we find the simple factors. we just simply add 1 in the powers and then multiply them. So I can say there are total of 4 factors. There are total of 4 factors that ends with 0. Or if I have to find the total number of factors, suppose the question is based on finding the total number of factors, I will just simply add 1 in the powers. I will say 3 multiplied by 2 multiplied by 2. So I can say 3 to 6, 6 to 12. So overall we have 12 factors. If we talk about overall number of factors, then we have 12 factors. But if I talk about the factors which end in 0, then I have 4 factors. Suppose the question is based on find the number of factors that does not end with 0. That does not end in 0. If I have to find the number of factors that does not end in 0, what shall I do? I will just simply subtract 12, or I will subtract 4 from 12. I will simply get the number of factors that does not end in 0. So what we can do, total number of factors minus the factors that end in 0. Total number of factors that end in 0, and we will get the factors that does not end in 0. So this is how we solve such kind of questions. Now please try to solve this question. The question is, what are the total number of factors in 180 that does not ends with 0? Now this is the same exact little bit different kind of question that we solved earlier. We have to find the number of factors that does not end in 0. So if I have to find the factors that does not end in 0, what I have to do is I have to find the total factors, and then I have to subtract the factors that ends in 0, because we don't have any direct method of finding the factors that does not end in 0. So let's find the total factors. Just find how many factors end in 0, and the remaining will be that does not end in 0. So total factors are, this 180 can be written as 3 multiply 3 multiply 2 multiply 5 and then multiply 2. Then we can write this one as 2 square multiplied by 3 square multiplied by 5 raised to the power 1. Now if I have to find the total factors, total number of factors equals, we used to add 1 in the powers and then multiply them. That is 2 plus 1 is 3, then 2 plus 1 is 3, and then 1 plus 1 is 2. So we get this one as 18 factors. Now if I have to find the number of factors that end in 0, number of factors that end in 0, what I have to do? I have to take 2 and 5 common out of it. That means the numbers that divisible by 10. So 10 is made up of 2 and 5, so taking out common, 2 and 5 common, remaining inside is 2 raised to the power 1 multiplied by 3 raised to the power 1. And then again following the same process, whatever powers we get, add 1 in them. This is 1 plus 1 is 2, then 1 plus 1 is 2, and I can say I have 4 factors that ends in 0. I can simply say that we have 4 factors that end in 0. So 180 we got, this is 2 square multiplied by 3 square multiplied by 5 raised to the power 1. Total factors 3 multiply 3 multiply 2, that is 18. Now ending in 0, what I do, I take common 2 and 5 out of it. So we get this 2 raised to the power 1, and sorry, this is 3 raised to the power 2. Now this will be 2 multiplied by 3, this will be equal to 6. So I get 6 numbers that ends in 0. It means the number of factors that does not end in 0 is equal to 18 minus 6, that is equal to 12. We can simply say there are 12 factors that does not end in 0. So the answer will be this last one, 12. Let us solve this another question. The question is, find the total number of factors of 2160 which are divisible by 6 but not by 9. Again, what we have to do, we have to find the total number of factors which are divisible by 6 but not by 9. So first of all, I have to factorize this number 216. 2160. Now 2160 is the cube of 6, so I can write this one as 6 multiply 6 multiply 6 multiply 2 multiply 5, and then this further can be written as so this is 2 raised to the power 4 multiplied by 3 raised to the power 3 multiplied by 5 raised to the power 1. So this is how I factorize this number. Now if I have to find the factors which are divisible by 6, now how we do that? Factors divisible by 6. Now we know this, that 6 is made up of 2 and 3. So what I will do, I will take out common 2 and 3 out of it. The remaining inside is 2 raised to the power 3 into 3 raised to the power 2 into 5 raised to the power 1, and then following the same process as we use to find the number of factors. So I can write this one as 3 plus 1 4, 2 plus 1 is 3, and 1 plus 1 is 2. So this is equal to 4 3 12 to 24. So we can say overall we have 24 factors that are divisible by 6. But as the question is, we have to find the factors which are divisible by 6, but they should not be divisible by 9. So what is the meaning of this? Whenever such kind of questions are asked, we always take the LCM. So the LCM of 6 and 9 is 18. That means we have to eliminate such kind of numbers which are divisible by 18. So 18, I can say 18 is made up of 3 times 9, 9 2 times 18. That is, this is how we can write 18 in the form of prime factors, 3 3 9 9 to 18. Now again taking this common out of the total number of factors, these are the total factors. Now if I take common out of them, what remains inside is, or we can write this one as, that is, this is 3 to the power 2. We can simply write this one like this, 3 square into 2 raised to the power 1. Now taking out common, what remains inside is 2 cube multiplied by 3 raised to the power 1 multiplied by 5 raised to the power 1. Now again following the same process as we use to find the number of factors. So I can say that this 3 plus 1 is 4, 1 plus 1 is 2, and then 1 plus 1 is 2. So this is 4 2 times is 8, 8 2 times is 16. So we have 16 factors that are divisible by 18. So we can say we have 16 factors that are divisible by 6 as well as by 9. So I need to subtract those factors. So we can say the factors which are divisible by 6 but not by 9 are 24 minus 16 is equal to 8. So 8 will be the answer for this question. So this is how we solve such kind of questions in which we have to eliminate the numbers like which are divisible by 6 and not by 9 just by taking the LCM. Now please try to solve this question number 9. As this question has already came in the SSC CGL exam 2 times. First time it came in the 2018 mains, and then it came in 19 again. Now the question is, when 200 is divided by a positive integer x, the remainder is 8, how many values of x are there? Now again this question is exactly related to finding the number of factors, but little bit twisted. Now in what way this question is twisted, we will see this. So first of all, they are saying when 200 is divided by a positive integer x, if I am dividing a number 200 by any number, they are saying the remainder in that case will be equal to 2. Now what is that number? Now this is a simple process. Whenever I have to find a number, I have to find such kind of number which when divide this 200 it will give remainder 8. I can simply say that 192 is the largest number which if divide this 200 will give us remainder 8. So how we got this 192? Just simply subtract this 8 from 200, I'll get this 192. I can say the maximum, there can be many different numbers, but the maximum number is 192. 192 is the number which if divides 200 will give us 8. Now they are saying how many values of x are there. X means how many values of this number are there. So how many values means they are simply asking us the factors. They are simply asking us to find the factors of this number. So what I will do, I will simply find the factors of this. Now 192 can be written as now if I write the number of factors of this, I can write this one as 2 raised to the power 6 multiplied by 3 raised to the power 1. So if I have to find the total number of factors in this, I can say total number of factors are 6 plus 1 is 7 multiplied by 1 plus 1 is 2. That is overall we have 14 factors. I can say overall we have 14 factors of 192. They are asking how many values of x are there. I can say there are 14 factors of 192. But the question is that when 200 is divided by this number 192, the remainder is 8. So how many values of x are there? That means when I factorize this 192, I get 14 different factors of 192. That is what I got. I got one factor as 2 raised to the power 0. Another factor is 2 raised to the power 1. Another one is 3, then 4, then 5 and then 6. Similarly, another one is 3 raised to the power 0, 3 raised to the power 1. What does it mean? I have explained this earlier as well. This can be written as 1 plus 2, then 8, then this is 16, then this is 32, then this is 64, then one number is 1, then another number is 3. And then we will multiply this 1 with all of these numbers, and then I will multiply this 3 with all of these numbers. But what they are asking is, when I divide this 200 by 192 or any factor of 192, the remainder should be equal to 8. So let us say the one factor of 192 is 2. 2 is the factor of 192. Now if I divide this 200 by 2, it is obvious that we will not get any remainder. 200 is completely divisible by 2. Similarly, when I divide this 200 by 8, then it is again exactly divisible by 8. There will be no such remainder. Similarly, when I divide this 200 by 1, as 1 is also the factor of 192, it is exactly divisible and it will not leave any remainder. Similarly, if I divide this 200 by 1 over here, it will again be divisible by, it is completely, I can say, divisible by 200. So we have to eliminate such kind of numbers which do not leave any remainder. So what we can do is, I already found it that there are total 14 factors. Now what we do, we simply write down the values starting from 1 like this, and then we have to see whether this number is the factor of 192 and whether this number is leaving any remainder or not. Like 1 is the factor of 192, and if 200 is divided by 1, it will not leave any remainder. Then another number is 2. 2 is also the factor of 192, and 2 when divides 200 will not leave any remainder. Similarly, another factor of 192 is 3. When 200 is divided by 3, obviously it will not leave remainder 8, because 3 is already smaller than 8. Then how it will give remainder bigger than itself? Similarly, another factor of 200 is 4. Like we have to count these numbers from 1 till 8, and then we have to eliminate such kind of numbers. 1, 2, 3, then another number is 4. Now just see whether 4 is the factor of 192 or not. We can say yes, 4 is the factor of 192, and 4 does not leave a remainder bigger than itself. So 4 is also there. Now we have to see, is 5 the factor of 192? We can say that 5 is not the factor of 192, so we don't have to write it. Then another number is 6. we can say, is 6 a factor of 192? Yes, 3 multiplied 2 is 6. 6 is the factor of 192, or you can simply see whether 192 is divisible by 6. Yes, 6 divides 192 and 6 is the factor. Now, can 6 leave remainder 8 when it divides 200? Obviously not, because 6 is already smaller than 8. How it can leave a remainder bigger than itself? Now, another number is 7, but 7 is not the factor of 192, so we don't have to write it. Another number is 8. Now we can see that 8 is the factor of 192, and 8 when divides 200, it gets completely divisible. It will not leave remainder 8. Now another number is 9. We don't have to count 9. Another number is 10. We don't even have to count 10. We only have to count the numbers till 8, because remainder is given to us 8. Alright. That means we have to count the smaller numbers than 8. We don't have to count the bigger numbers than 8. Bigger numbers than 8 will obviously can leave the remainder 8. So I can say there are 1, 2, 3, 4, 5, 6. There are 6 numbers, or there are 6 factors of 192 that will not leave a remainder 8. So what I can do, I have to subtract total number of the numbers which do not leave remainder 8 from 14. So we can say total number of factors which do not leave remainder 8 are 6, and answer will be 14 minus 6, that is equal to 8. So overall there are 8 factors that leave remainder 8 when they divide 200. So the question was simple. You just have to understand like what they are asking in this. So you just simply have to first of all identify the number, write down its total factors, and then after writing the total factors, you have to count all the numbers less than till 8 starting from 1, like 1, 2, 3, and then you also have to check whether these are the factors or not. Don't just write abruptly, like if you're writing 5 is obviously not the factor of 192, so we don't have to count it. Similarly, 7 is also not the factor of 192, so we only have to count the factors of 192 less than 8. That's it. So 1, 2, 3, 4, 5, 6 factors less than 8. So 14 minus 6 equals to 8. This will be the answer. Let us try to solve this last question in this series. The question is, if n equals 2 raised to the power 4, 3 raised to the power 4 and 5 raised to the power 4, find the total number of factors of n that ends with only 1 0. Question is the factors that ends with only 1 0. What is the meaning of this? Let us try to understand this. Now, that ends with only 1 0 means there can be factors that can end with 2 zeros, that can also end with 3 zeros, that can also end with 4 zeros. Suppose I have to find the total number of factors. Now, total number of factors in this one is, as it is already written in the primes, 2 is also a prime number, 3 is also a prime number, and 5 is also a prime number. So I simply have to add 1 in their powers, that is 5 multiply 5 multiply 5. I can say there are overall 125 factors of the number given to us. But we have to find the numbers that ends with only 1 0. What is the meaning of this? Let us try to understand this. Now if I open this number and if I write it down like this, now I am just showing you that what is the meaning of this question. We can write this one as 1 plus 2 plus 4 plus 8 plus 16, and this can be written as 1 plus 3 plus 9 plus 27 plus 81, and then this further can be written as different. We can write all the values of all of them. Now if when these numbers get multiplied, for example, I am not multiplying these ones, I am just concentrating here on 5 and then this 2. If I multiply this 1 with all these values, I get all these values as it is. When I multiply this 5 with all these values, what I will get? I will get 5 as one of the factor. When this 5 is multiplied with 2, I will get 10 plus 20 plus 5 8 times is 40 plus 5 16 times is 80. Now when this 25 will get multiplied with all these numbers, what I will get is 25 plus 25 2 times is 50 plus 100 plus 200, and then this another one will be 350, and then after this 25 I can write this 5 cube as 125. When this 125 get multiplied with all these numbers, I can write the numbers further as 125 with this one 125 plus 125 2 times is 250 plus 600 plus 1000 plus you will get some number over here. So what I am saying is I only have to count such kind of numbers. Now all of these are factors. Now if you want to find more factors, then also multiply these numbers with all of them. So I have just multiplied some values of 5, 25 and 125 with this. I got some factors. This 10 is the factor, 20, 40, 80. These factors only have 1 zeros. But if I talk about 100, it has 2 zeros. This also has 2 zeros. Then this 600 has 2 zeros and 1000 also has 2 zeros. Now if I write this 5 raised to the power 4, if I write down the value of this, it will be equal to 625. And then if I multiply 625 with all these values, I will get one more zeros along with some of the numbers. So what I am trying to show you is what I have to do for finding the numbers that only end with 1 0. I have to find the total number of factors. I have to find the total number of factors that ends in 1 0, that ends in 1 0, because there will be more number of factors that ends in 1 0, and then I have to subtract the total number of factors that end in 2 zeros, that end in 2 zeros. So please try to understand this. I have to find the total number of factors that end in 1 0 minus total number of factors that end in 2 zeros. Now total number of factors that end in 1 0 is this. I have this factor 1, 2, 3, 4, 5. Then I have this 6. Then I have this 7. Then all these numbers are ending in 1 0. And then I have to subtract total number of factors that end in 2 zeros out of them. So for this, what I have to do, 2 zeros means that 1000 also have 2 zeros, and then this 100 already has 2 zeros, this 200 already has 2 zeros. So we have to eliminate such kind of numbers. So for numbers that ends in 1 0, it means I have to take 2 raised to the power 1 into 5 raised to the power 1 common out of them. Then the answer will be, if I take common out of them, the remaining inside will be 2 raised to the power 3 into 3 raised to the power 4 into 5 raised to the power 3. Similarly, this number can be written as, for ending in 2 zeros, it means I have to take 100 common out of it. So 2 square multiplied by 5 square, and the remaining inside will be 2 raised to the power 2 into 3 raised to the power 4 multiplied by 5 raised to the power 2. And then we have to follow the same process that we follow for finding the number of factors. So I can simply say that this can be written as 3 plus 1 is 4 multiplied by 5 multiplied by 4. This will be equal to minus, this will be equal to 3 multiplied by 4 plus 1 is 5 multiplied by 2 plus 1 is 3. So this will be equal to, I can write this one as, this is 4 4 16, or 5 times is 80 minus 3 3 9 5 45, and then this will be equal to 35. So I can say overall there are 35 factors that only ends in 1 0. There are total of 35 factors that ends with 1 0. So this is how we solve such kind of questions. I hope all of you understand all these questions.